Wet, Curl, and Jill, and done with it. So. All right, how about 2A? Yay or nay? You want me to just go through the whole thing? Okay, yep. All right, so I've got, the curve says x equals y squared, but that's because it's both sides. And if you read the first part, it says y equals negative square root of x and y equals square root of x. So that what I essentially have is this parabola on its side. So this is square root of x, this is negative square root of x. So this distance is 2 times the square root of x, right? Kind of like the one we did yesterday. All right, so the first one says that there are the cross sections are circular discs with diameters in the xy plane. So in other words, this is that bottom one is way off. It's okay. Is the diameter of a circle, right? So what all it asked me to do was find an equation for the area of the cross section that's given. So what's the area of one cross section, which is one circle? So how do you find the area of a circle? Pi r squared. So the question is, what's the radius of this circle? Square root of x, because it's half the diameter. Half the diameter is from here to here, so this would be the radius, and that distance is square root of x because it's up to that graph, right? So the area of this would be pi times square root of x squared, or x pi, or pi x, either one. Does that make sense? That's all you had to do. Part B says that the cross sections are squares with bases in the xy plane. So this time, from here to here is my base of a square, right? Or my side length of the square. Well, if the side length, what is the side length from top to bottom? 2 square root of x's, right? Because from the x-axis up, it's square root of x, so 2 of them, 2 square root of x. Yeah, absolutely. Yeah, go ahead. Yeah, I have love in there. All right, so does that make sense? The base of that square that's sitting in the plane, that cross section, its side length is 2 square root of x. Right? This one's a square root of x, this one's a square root of x. So together it's 2 of those. So the area of the square is just the side squared. Right? Side times side, because it's square, all sides are the same. So I get 4x. Does that make sense? Yes, man, that makes perfect sense. Thank you. Okay, no, I'm just kidding. Okay. Part C. The cross sections are squares with diagonals in the xy plane. So this time I've got this square, and here's where we get into our 45, 45, 90 triangles, right? This length is 2 times the square root of x. And I need the area of that square. So how do I get back to a leg of a 45, 45, 90 triangle from the hypotenuse? Y'all can do this. Divide by square root of 2. That's exactly right. So this side is this divided by square root of 2. I can clean it up just a little bit by multiplying by the square root of 2. This is not necessary. I'm just a little extra, as we all know. Over 2, that cancels out. So this side is just the square root of 2x. Are y'all okay there? So what is the area of the square whose diagonal sits on the xy plane? Yes. It's still clean up whenever you square it. It's just this squared, right? Square root of 2x squared, which is just 2x. Does that make sense? If you had left it this way and squared it, so 2 root x over square root of 2, if I squared this, I'd get 4x over 2, which is 2x. because the area of a square is side times side. Pi r squared. So that's the radius squared. So we squared half of it for the radius squared. Base is in the xy plane, so now that's the base. So the base is 2 square root of x. It's equilateral, which means all the sides are the same. But what I really need, since that's a terrible equilateral triangle, but that's okay. What I really need is the height that comes in right here, right? Because the area of a triangle is, of course, 1/2 base times height. I have the base, I don't have the height. So if I've got a 30, 60, 90 triangle, first of all, what's this short side here? Square root of x, because if the whole thing is 2 square root of x's, then one of them would just be square root of x, right? So how do I go from the short leg to the long leg? You'll remember. Square root of 3. The hypotenuse is doubled, the long leg is square root of 3. So I do square root of 3 times the square root of x, which is just the square root of 3x. Now I have enough information to find the area of the triangle. So the area is 1/2 base times height, which is just all right to crank it up. Yes. Well, so an equilateral triangle breaks into 2 separate 30, 60, 90 triangles. That's why I had to cut it in half to find this leg, so that I could get the long leg. But the whole area of this big triangle, so this whole base here is 2 square root of x. And then the height of the triangle is square root of 3x. Start easy. Find the volume of the solid. So now we're actually going to remember, volume is just the integral of the area of the cross section. But we evaluate from wherever to whatever, and that'll give us the volume of that 3-dimensional shape with those cross sections cut out. All right, let's say the solid lies between planes. This is number 5, by the way. Oh, okay. Perpendicular to the x-axis at x equals -1 and x equals 1. The cross sections perpendicular to the x-axis between these planes are squares whose bases run from the semicircle y equals negative square root of 1 minus x squared and y equals 1 minus x squared. Find the area, and it said from x equals -1 to x equals 1. Find the volume, the volume of the solid. Well, to find the volume of the solid, the first thing I need to do is find the area of one cross section, right? And it said that the cross sections are squares whose side length runs between these two. Well, let's graph it and see what it looks like. And now I'm going from -1 to 1. I feel like we did one kind of like this yesterday, did we? I don't know why my circles never look like circles. They always look like that's not terrible. All right, so this is up top, we have the square root of 1 minus x squared, and on the bottom we have negative square root of 1 minus x squared. Is everybody with me? No. This is just words. Well, it said the semicircle y equals negative 1 minus x squared to the semicircle square root of 1 minus x squared. So it gave me the equations. And I know that this is a semicircle. If you were to write this in circle form, like if you squared both sides, right, I'd have y squared equals 1 minus x squared. And you could have x squared plus y squared equals 1. That's a circle with radius 1. All right, so now what I want to do, this is a non-calculator problem, by the way. So now what I need to do, remember the hardest part is finding the area of the cross-section. So I need the area of a square whose side runs from one semicircle to the other. So there's my side length. Y'all okay there? So what's the area of the square? What's the side length? 2. That's exactly right. 2 of these distances, right? So 2 of those. So for area, I'm going to square it. Are we all okay there? I'm going to clean it up just a little bit because I do have to evaluate a volume here, which means I'm going to have to do an integral. And so I'm going to want it in an easily evaluatable form. So I'm going to make this 4 times 1 minus x squared. I think that just might help me just a bit as I evaluate an integral. So now because it asks for volume, and I want the volume of the whole thing stretching from -1 to 1, because that's what it told me, from -1 to 1, then the volume is going to be the integral from -1 to 1 of 4 minus 4x squared. Everybody okay? What's the antiderivative here? 4x minus crickets. What's the antiderivative of 4x squared? 4/3 x cubed. That's right. And I'm evaluating from -1 to 1. Do I? No, see, because it's definite. I've got bounds there. All right, so we'll plug in -1. And we'll plug in. Yeah. Do we what? Oh, I did it backwards, didn't I? I'm sitting here going, why am I getting a negative? Sorry. Yeah, I bet people are going to go back and watch my videos and go, what an idiot. No, nobody will go back and watch them. Okay. I did that on purpose. Make sure you're paying attention. 4 minus 4/3 minus -4 plus 4/3. Right? Maybe I should go back to the way I did in algebra. Just same change everything and be done with it. Okay, which is no. No, I can't have any distractions. I just messed up on a problem. I mean, I did it right and thought I messed up. What? Okay. I don't have a lot of cross section practice in here. Everything else is volumes by rotation. That's not what we want. We'll do that tomorrow, not today. Ooh, better practice. Let's say we are bounded by the y-axis. Y equals sine x and y equals 1 between 0 and pi over 2. And let's say each cross section, they say perpendicular to the y-axis. Let's don't do it with respect. Well, let's do it with respect. Let's say each cross section perpendicular to the x-axis is a semicircle. Hey, you're fine. Find the volume. That's it. That was the whole problem. Find the volume. Each cross section is perpendicular to the x-axis and it's a semicircle. So let's look at the area first, because they do give you at least a graph so you can see the shaded region here. So if I'm bounded by the y-axis, that's here, right? And the line y equals 1 is here. So all I need to graph is sine x. What's the sine of 0? And I'm going by, I should probably put this, since it only says to go from 0 to pi over 2, I'll come here. What's the sine of pi over 2? 1. This is where it curves up, right? So the graph of sine looks something like this here. If it kept going, this is where it would curve down. But this is the area that I'm looking at. Do we all agree? Do we see why? Does that make sense? It says that it's bounded by the y-axis, which is here. So that says stop, don't go any further than this. And then it's bounded by the graph y equals sine x. So I draw that. So it's bounding it in somewhere. And then it's also bounded by the line y equals 1. So I draw all those lines, and what's the shape that's bounded in between? And it's this funny little curvature of a shape. Everybody okay on how I found the shape? All right. So we need the volume using circular cross sections. Semicircle, actually, not circle. What's the difference? Half. It's just half of a circle. So my first question is, I guess we'll walk through this together. Y'all look at me like I don't even know where to start. So the first question is, how do you find the area of a semicircle? Not just this one, but in general, what's the area of a semicircle? 1/2 pi r squared. Are we in agreement there? Okay. 1/2 pi r squared. So now, what's the area of my semicircle? So if this, that would be the what of the semicircle? That's the diameter of the semicircle. Are we all in agreement there? And diameter, I have to do half of that to find radius, which is what I need here, right? So now my question is, well, first let's just find that black length right there. Because it said each cross section is a semicircle, so that means the diameter sits there. If it was a square, that'd be the side length. If it was an equilateral triangle, that would be the base of it. So what's the whole diameter there? Look at y'all. The diameter is 1 minus sine x. All the way up is 1, but I take out this sine x this here. Y'all are going to do great with revolution, volume by revolution. So if you can see the hole that's there, then you'll be fine. All right, so what's the diameter, the radius then? Half of that, right? So 1 minus sine x divided by 2, or half times 1 minus, any of those work. So what's the area of one semicircle whose diameter sits there in that shaded region? 1/2 pi times, that's right, 1 minus sine x over 2 squared. Y'all okay? I'm probably just going to leave this as is and assume that this is probably going to be a calculator problem. So now for the volume, if I want the volume of this solid, what do I do? I got to integrate. From what to what? Pi over 2. That's exactly right. Are y'all okay there? And then I just do the area. Pi over 2, 1 minus sine x over 2 squared. Yeah. Y'all okay? I would use my calculator for this because I do not know the antiderivative of 1 minus sine x squared. What if I switched it up? Okay. I would type this into y1, and then I do math. Let's see what we get. So in y1, I'm putting pi over 2. And then be careful with your parentheses here. Yes. Sine x squared. Close the top, divide by 2, close that, and squared. 1, 2, 3, 4. 1, 2, 3, 4. Okay. I got 0.2313. Is that what y'all got? No? What'd you get? Oh, let me make sure this is in radians. Are y'all in radians or degrees? In radians. And what did y'all get? Everybody got something different? You didn't do it, Henry. What the heck? I was like, you got an even pie. What the heck? What did you get? That's not what I. Both of y'all got the same thing. Pi over 2. Never mind. Okay. You got 4? What did y'all get? One, 3, 9, 8. Okay. That's what I got. It's really it's the inputting of the, it's like you say, it's the inputting of the fractions with the parentheses and stuff. I kept squaring the so I mean you gotta have parentheses here, you gotta have parentheses here, you gotta have parentheses here. Makes lots of places for mistakes. But yes, it should be 0.139877. At least 3. Go 4 to be sure. You got, yeah. Let's change this. And let's say, instead of the cross sections perpendicular to the x-axis, let's say that the cross sections are perpendicular to the y-axis. What happens? So now what happens? Flip the diameter. Okay, well, if I flip the diameter, so I'm going from here to here now. Get another color. That doesn't show up well. You're exactly right. I've got to solve it for x now, because to know that length, right, this is y equals sine x. What would x equal? If that's y equals sine x, what does x equal? What? There you go. Inverse sine of x. Oh, y, sorry. Right, but that's how we solve, that's how we get it by itself. So now what I'm doing, now I'm saying my diameter of my semicircle is the inverse sine of y. So what's the radius? That over 2. So now what's the area of my semicircle? 1/2, or pi over 2 times, that's right, inverse sine y over 2 squared. So now what's the volume of my solid? Take the integral from what to what? Be 0 to 1. This time I'm talking all about y's and only y's. That means I'm going to keep taking these diameters until I get up to 1. So I'm going to go from 0 to 1. And again, I'm on my calculator because I do not know the antiderivative of that. There's no white space there. See, it runs slap up to the axis. For your calculator, yes, you can, because the variable itself doesn't matter there since they're the same there as you put in. What do you think about cross sections? They're fine? I think so too. Y'all want to do one more? Or are you good? I don't know what the answer is. I didn't. What'd y'all get? So whatever I got, 0.183. I'm going to give y'all one to work on. This is number 9 on your homework. I'm going to give y'all one to work on while I go run and make this copy. Find the volume of the solid that is bounded by y equals the square root of x, y equals x over 3. Cross sections perpendicular to the, this says y-axis. Again, semicircles. We should do one that's not semicircles. Yeah, let's do 8. Sorry. There you go. Bounded by y equals e to the x, x equals 1, and it's perpendicular to the y-axis. They're equilateral triangles cross section. Well, I'm going to say to the y-axis. It's bounded by the y-axis also. The picture is drawn for you. I'll draw the picture. Looks like this. There's your area. So with respect to x, my cross sections are doing this, right? Nope, I lied. This. Perpendicular to the x-axis. So this, if I'm talking about equilateral triangles, what's the base of my triangle? E to the x. Remember, area is 1/2 base times height. But because it's an equilateral triangle, my height drops down like this. So this is e to the x, which means, but I need to know half of that. So I'm just going to say it's half e to the x. And then to get from that short leg to the long leg, which is the height, I'm going to multiply by the square root of 3. So I get square root of 3 over 2 times e to the x. Everybody okay there? So the area of one triangle here is 1/2 base, which we said was e to the x, times height, which we said was square root of 3 over 2 e to the x. I just kind of put these together. This would be square root of 3 over 4. E to the x times e to the x would be e to the 2x. So then for the volume, I'm just going integral from 0 to 1, square root of 3 over 4 e to the 2x dx. A lot of your FRQs, if it's something that's kind of difficult to work with or anything like that, this one you actually could find the antiderivative here, right? Maybe. You'd have to do a little u substitution, but you could do it. You could do it. But a lot of them that are difficult like this will say set up but do not evaluate an integral that would give the volume of the. I won't waste time walking through. Do y'all need me to evaluate that? I don't mind. Okay. Now if I go the other way, this is where it gets hard, right? So this equation, and I actually, I didn't, whenever I did it, I didn't split it into two, because if you do, if I stop at E, if I say that distance, bless you. I would have to say that it's also bounded by the y-axis. I would have to say, well, I might not have done it correctly on that paper. I jotted down real quick. Those are consistently the same until I hit 1, right? That's the point when that changes. So from 0 to 1, the area of each triangle, so that's 1/2, so this is square root of 3 over 2, right? The area of each of those triangles would be 1/2 base times height. Consistently, so it's a constant. Do you agree? Okay, so it's, what's this, square root of 3 over 4? Then I would do from 1 to E. So that's here. And again, I do need to solve that for, I think Alex said that earlier. Solve that for x. So if this is y equals e to the x, then what does x equal? Natural log of y. I think I messed up on that one. Don't follow me up on that one. I was jotting really, really quick. So here, this, oh, here's y, Alex, here's y. From here to here would be natural log of y, right? But I need this, right? So I have to take the whole thing, which is 1, and I have to subtract the natural log of y. Actually, that's not the integral. That's just the base. That's just the base. The base is 1 minus log y. That's why I have all that gobbledygook on there. Getting ahead of myself. So now if I cut it in half, here's my height. So my base is 1 minus log y. Half of this is the short side, so I need to multiply that by square root of 3 to get to the long leg, right? So I get the height is the square root of 3 times 1/2 1 minus log y. See why this one was so much harder? Now put them together for the area of your triangle. 1/2 base times height. And this is where, if you were following my work on that little notebook, piece of notebook paper, I just put these squared and I multiplied these two together. So I got square root of 3 over 4 and then 1 minus log y squared. That's the area of my triangle. So this is square root of 3 over 4, 1 minus log y squared. Look at your y value. They gave me this point in the original graph, 1e. These are tough, and I know these are tough. These they lead us right into volumes of revolution. I mean, if you can do these, you can do volumes of revolution, no problem, because they're just circles and disks and things like that. But it's what it's setting up for. On your calculator, that would be a strictly calculator problem. I mean, you could obviously do this one. That would just be square root of 3 over 4. But the other you need to calculate. So that's this constant part here I cut off, because in that part all the way down I have this constant base for each triangle will have the exact same base going through there, so they'll all look the same. They won't start changing until I get to this part. What do you mean?